Hi folks, welcome to another Wednesday Widget by NYC CNC. Today we're actually going to do a fun project. I'm really excited. There have been a ton of new products in the last few years for DSLR cameras and sort of home or prosumer level photography. I think it's awesome. In some respects I'm kind of in that boat because I do the YouTube videos and I really try to focus on good quality, but really what a lot of these products are for are real filmmakers where they're doing action shots. They need stabilizers, tracks, gear, all that stuff. It's a really cool industry. I've always kind of laughed because it seems like that's like what Kickstarter is a lot of that kind of stuff. I had someone shoot me an email and say, hey, I've always wanted to have a fun project for a slider. My husband wants one and wondering, you know, some of them are rinky dink or they're cheap. You know, what are the better options for higher quality stuff? And I thought, man, this should be easy. So what are the attributes that'll make this successful? I think it needs to be modular. I think it needs to be pretty inexpensive. So what I came up with is this design here that you see. What I think I like about it, and there may well be someone who's done this exact same thing, I don't know, but it will use standard, in my case I'm using black pipe that you can pick up from Home Depot, Lowe's, or any sort of hardware store, but you can also probably use other things that are about the same diameter, whether it's PVC or solid copper or steel. And if it's slightly undersized, you should be able to, you know, wrap tape or something around it and then use the set screw to shim it. And then we've got this roller block, but then what I think, hopefully, knock on wood, is a really good answer is the wheels. And I found these on eBay for a really good price. There's a link in the video description. And I thought, I've got this new Tormach lathe, we'll just make these, it'll be great. And then I found these and they look perfect. And here's the thing, I can't touch them for this price, especially since they include nice bearings themselves. So hopefully when we put this thing together, it'll slide pretty nice. We've got a few extra accessory threaded holes, whether you're trying to mount the whole stand on 2 tripods or on stakes, or you want to put a different type of camera or a slider thing on it. Hopefully should be good. As you guys saw in some of the videos I've made recently when I've had someone helping me film, a slider can really help for static shots, for conversation and dialogue, and obviously for filmmakers where they need a lot more sort of artistic input on the content than I do on some of these videos. The point of this project is a multi-fold project. One, I'm going to send this to the person who asked for it, who's someone that's really helped me out. So Jenna, hope you enjoy this. And then hopefully you guys will be able to do this yourself. I would love to see people that have access to equipment or even maker spaces go do this design. It's pretty simple. If you've got access to really a drill press, you should be able to do this. You know, you don't have to have all the machine perfect faces like we're doing here. We are going to offer the end blocks and the middle plate for sale on the Saunders Machine Works website. You could buy the wheels yourself, and you can go buy the whatever length rod you want, because obviously that's expensive to ship, and you can then buy it locally. So if you want to do that, you can buy them from SaundersMachineWorks.com. There's a link in the video, but that's not my point. Is not to turn this into a commercial video, but rather to learn. Let's take a quick look at the SolidWorks. Let's get the toolpaths down in SprutCAM, and then let's make this thing on the Tormach PCNC mill, and then we're going to assemble it, and we'll see how she works. Okay, so again, here's the design, and it's pretty simple. We've got the 2 end plates that will hold the pipe with either a decent close fit, but then with set screws on the top. And then it's simple. We've got this little block with a slider with the 4 wheels on it that acts as the actual slider. And I made it big enough, I hope, that it's stable. I've got 1/4 20 for a camera, 1 3/8/16, which I think is a common larger sized tripod mount. And you could put a camera sort of close to right on this thing, or you could put a tripod head on it. A few options there. And then the other 1/4 20 is my idea for this bottom strap, which if you put it on, and sorry, it's not modeled sort of correctly, it'll rest up closer to the bars. That will let you sort of secure it so that it won't necessarily prevent it from jostling around if it gets knocked over, but hopefully that will keep this from flying off completely. So very simple from a CAD standpoint rather. We've got obviously our holes for the wheels and the holes in the top. I added this hole here. I thought maybe, and I'm not a film guy per se, but if you wanted to put a little screw or rod sticking out here, that would give you something to move the camera left and right with instead of having to actually touch and hold the body of the camera itself. Yeah, just an idea. And then in the bottom of the blocks, we've got 3/4 20 holes, which the center ones I thought would be okay if you wanted to put a tripod underneath each of these to have the slider up in the air. And then the outside 2 could be used if you wanted to thread into like a table or posts or stakes to raise it off the ground, something like that. So if you guys have questions on the CAD, let me know. I'll be happy to go into it more in detail, but otherwise let's hop into SprutCAM and take a look at our toolpaths. So here's our end block. First thing we're going to do is I'm going to drill a 1/2 inch hole. That's going to give me this. So it gives me a good clearance hole, and then we're going to use this 1/2 inch rougher to come in and rough out most of the material, but we'll leave a little bit of material left for this final tool, which will be a cleanup. Pretty simple from a cam standpoint. Quick look at speeds and feeds. 1/2 inch drill we're doing at 1175 and 5.5. I love that recipe. It works great on the Tormach. We're going to do 2.2 inch pecking with a full retract. On the roughing waterline, we're using my go-to Mera tool 1/2 inch, tool 11, 2800 and 10 inches a minute, and we will go down all the way through the part in 2 passes, and we'll leave 10 thou stock. It should be okay. We'll see. That may be a little bit of an aggressive cut, as long as you get the chips out of there. And then the cleanup is my long 3/8 inch end mill tool 100, 5110, and we'll go. I'm actually going further down than you need to because I want to use the shorter part of the tool that's more rigid, and that's only taking 10 thou, so we do it in 1 pass. We'll bang through the rest of the cam real quick just so you guys can see the top here of these plates. Oops, 1 second. Pretty darn simple. I didn't label these, sorry, but spot, drill, tap. Number 4 drill at 3600 and 12 inches a minute, and we don't need to peck it because it's a pretty shallow hole. And then tapping is tool 51 for me, 420. We will do a 1/2 second dwell at the bottom, and that should work great on the Tormach. The plate itself, again, pretty simple. We're going to do a spot. We're going to chamfer around the edge, which should be nice. Drill, tap. We're going to drill this 5/16. I'm not going to tap it 3/8/16 with the compression head. I'll talk about that when we actually do it. I'm going to do it by hand in the Tormach. A personal preference, not in any way representative of the Tormach not being capable of doing it, but it's a personal choice, and I'm going to be honest with you that I think it's a safer way for me in a low production thing to just do it this way, at least for now. We may change that. This only thing here that's really different, chamfering, tool 25, which is a mill drill, 5120. You can move pretty fast, and we're going to chamfer down, down 50 thou, but over 20 thou. So that actually would be a 30 thou chamfer. You go down further than you want when you come out, and that means you're not going to chamfer with the tip of the tool. You guys have heard me talk about that a ton. We scroll in here, whoop, and look. You can see how the end of the tool is not being used. That's a little bit easier on your chamfering tools when you do it that way. So let's see here. Oh, last thing would be plate side 2. Just simple our M8 taps, and again I've got these programs, so you know what, we'll go ahead and run those in the Tormach itself. So nothing crazy there. H is the pre-drill for that tap, and the middle one's a 1/4-20. Pretty simple at this point, folks. Let's make some chips. Okay, part is in the vise. I use a 1-2-3 block on only the rear jaw when I put it in the vise. That'll let this be plenty repeatable enough to put the second piece in and not have to re-zero. And you'd be amazed, folks. Use your fingers. You can really feel if that's lined up. Then I take a dead blow hammer. You do, and this you're going to laugh about, is there really a lot to be learned about how to hammer, but one smack, hold it at the rear of the base, and don't grab the hammer. Kind of let it relax. I used to hammer well, it's hard to do it now, but I used to hammer and not let the hammer do the work. I tried to force it down. Just let it snap down only once. Your parallels are solid. Now, I've had a lot of folks ask about how I use the hammer, so let's do a little video, and hopefully I'll be able to show you guys why I both love the hammer and why I love using the keyboard over that stupid jog shuttle. Okay, so we choose tool 99 in Path Pilot, Jog down the Z first, get close, switch over to 10,000ths of an inch, and page down to there, hit Z0, switch back, continuous, come over, come in on the X, get close, thousandths, close, actually that's spot on, 0 and X, switch back to jog, come in on the Y, switch to thousandths, that's close right there, boom, boom, boom. That's it, folks, pretty simple, right? Jog up, I always do my sanity check, there, and there, looks good. And that's it. We obviously want to use the rear jaw because that jaw doesn't move, so if you switch to a part that's, say, far deeper or wider, but you still have the same Y reference, makes it a little bit easier. All right, here we go. I love this drill. It's just, drilling is, I think, can be quite smart rather than trying to do a plunge with the roughing end mill, which you can. It's a center cutting end mill, but it's hard on it and it's harder. It's just, I love this method of clearance with holes. And there's a lot of folks that will actually do this on major material removal, whether peck drill or gang drill along and then come in and clean up. You got to be a little bit careful because sometimes you can have a pretty uneven chip load when you do that. But again, it's just all about the cutting recipe. If you do a more solid end mill to bang through that stuff and then come in with a finished cleanup, it can be a great result. But on this drill, I mean, look at that. Look at that nice long chip we're making there. I love it. Tool changers, rock solid. It's great for jobs like this. You know, I can have this thing make a ton of these blocks in an afternoon, and all I need to do is come over every few minutes and just throw a new one in the plate or in the vise, which is already indexed, so that doesn't even take any real time, or you don't have to think. So here you go. Now you see, now we're going down. How far? Yeah. We're going down over ½ an inch. So that's a big cut, but it's handling it. You hear a little bit of chatter. That's okay though, because it's it's going to get a finished cleanup patch. You got to get the chips out of there. It's another reason why I love, because you've got that drilled hole, the chips can fall through, which is really important. This is one of those too where I don't know if flood coolant would be better or not. The air blast from this Trico really does a good job of blowing chips out. But folks, that's a pretty good beefy cut right there. And actually the surface finish is pretty darn good. A moot point since we're gonna clean it up right now anyway, but well, yeah. And then tool 100. Sorry folks, I goofed. I thought I actually had that one in the changer, but I don't, so it's just asking for it, and I put it in, and click cycle start. I need to set up a thing so I can preview the GoPro camera. I'm actually going to use an old iPhone, to leave it on that Wi-Fi GoPro network to take a look. So there we're down 1.4 thou. 1.4 inches for a quick cleanup, 10 thou. This end mill usually leaves a great finish. And sorry, what was I saying? Oh, I need to be able to preview the GoPro angle and camera shot so I make sure that looks good. I'm kind of going blind here, but hopefully it'll be okay. But look, it's just that simple. We made two, I think these are 860 thou holes pretty darn quickly. And if I make these in really high production, I'll build a fixture and put a bunch in the machine at once. All right, let's drill and tap the top.